Assalamu alaikum. Today we will be discussing our fourth topic in this series, and this would be about atoms and ions. According to your syllabus, candidates should be able to state, first of all, the relative charges and approximate relative masses of a proton, neutron, and an electron. So for that, you just primarily need to know one thing. Here I will draw a table. Now if you look at this table, this table basically shows there are three types of subatomic particles based on your course: protons, neutrons, and electrons. And then you need to know the atomic mass unit, which is primarily known as AMU, and you need to know the charge on each one of these three. Now first of all, proton has an atomic mass unit of 1. Then you can look at its charge, which is +1. Then a neutron has an AMU of 1. The charge is 0. And the mass, the AMU of an electron is 1 divided by 1840, and then the charge is -1. Simply looking at this table, you just need to know these values for your exams. Now, as you can see in the table, the different atomic mass units of protons, neutrons, and electrons, and then their relative charges. Proton has a positive charge of +1. Then you have neutron, which has no charge, and then you have electron, which has a charge of -1. So pretty much this information you just need to know for your exams. Now, if we look at protons and neutrons, they are specifically found in the nucleus of an atom. They are collectively known as nucleons. On the other hand, electrons are found outside the nucleus. They are arranged in shells, also referred to as energy levels, which surround the nucleus. Now, for example, if you see that there is an atom, let's say this is an element which is X. Now this element has a nucleus. Now this nucleus contains, what does it contain? Protons and neutrons. Let's say protons are denoted by P, and N is for neutron and E is for electron. So the nucleus of an element contains protons and neutrons, and if you come outside the nucleus, there are different shells which has electrons. And how many protons and neutrons there would be and how many electrons there would be, it depends upon the element. Let's, for example, let's just first of all look at another diagram. Now, if you look at a depiction of any chemical symbol, let's say there is a symbol X, and it is noted. This is shown as X, and it has a nucleon number of A, and then it has a proton number of Z, and this is for element X. So always remember that each element is represented by a unique chemical symbol in the periodic table. The letter A shows the nucleon number, or you can also call it the mass number. This is either called nucleon number or mass number. Basically, the nucleon number or the mass number gives the total number of protons and neutrons in the nucleus of an atom. Let's say that there is an element. In the nucleus of that element, you have a nucleon number of 50 and a proton number of 20. So if you want to calculate the number of neutrons in that element X, what you would do is that you would simply subtract 20 from 50, because this is the number of protons. So in order to calculate the number of neutrons in element X, you can simply subtract proton number from mass number. You will get number of neutrons. Now this Z is basically the proton number. Now this Z number, the proton number, also shows the number of electrons in the shells of this element, in the atoms of this element. Let's say, as I've told earlier, that if the proton number is 20, so this basically means the number of protons and number of electrons in that element are equally 20.